Okay, now we're recording. Thanks. It even has a sound effect. You can't hear from over there, but it's got a sound effect. It's Halloween. Okay. Welcome to whatever week this is now. I've lost track. That's about it. Just gonna wait till everybody settles down. All right, so tonight's the drop dead time for the first assignment. Good news is almost everybody submitted it. First time ever. By drop dead, I mean after midnight I no longer accept it. Or unless there's a prior engagement, and so far nobody's made a prior engagement. It's a little late to make a prior engagement. What's happening today? I'm covering joins and other stuff, and this is by far the hardest part of SQL. I will do my best try to explain it so it makes sense. If it does, great for us. If it doesn't, well, we'll keep trying. And then I assign more work. But that's just how this works at this stage of the game. All right, so I'm going to talk about joins. It's going to be another show and tell class. Essentially, what I'm going to be covering is inner joins, left-right joins, and then I'm going to talk about subqueries. The SQL languages are a very powerful language. Some people start realizing at this point that it's surprisingly flexible. And actually, the surprising thing about it is that once you add these things into the mix, SQL is almost limitless as far as messing with data. The amount of stuff you can do with it's pretty amazing. I'm going to start with the inner join. And I actually have a matching diagram that goes with this that I'll be putting on Blackboard. I used to use a Venn diagram for this until I had another teacher prove to me that using Venn diagrams for this was stupid, and they were completely right. Even at my age, you still learn something. And he was right about what he said. Venn diagrams are for set operations, not matching up data. So he showed me an alternate way to teach it. It makes so much more sense. I wish I'd known about this 10 years ago. It would have made this explanation so much simpler. Okay, there's the inner join. The inner join is used to connect two tables, and it retrieves data from both tables where there's a match between the two. There's two syntaxes. Actually, there's a third syntax, and I don't teach it because it's a little weird. But there's the old syntax and the new syntax. For this course, I will be using the new syntax, just so you know. And then the old syntax, I'll still accept work submitted using the old syntax, but just so that you know, it's been deprecated. It's not quite frowned upon, but we all have that friend that drives a car that's 15 years old. And I'm not talking about, don't pay attention to that, that's just my video card blinking. Drives the old Civic, and he's not a racer. He's just, driving a 15-year-old Civic. And it runs a little rough, and things are a little weird. That's the old syntax as far as doing joins in SQL. The new syntax is it's actually longer, but it's actually more, it's clearer to what's happening. Then there's a command called the inner join. And with the inner, you can skip the word inner. So if ever you see a command that uses the word join, it's assuming inner, unless you tell it otherwise. Now, let's see how well this scales up in here. So, the top one's an inner join. So I'm using different colors to point out different matching criteria. So you got a table that has numbers and a table has letters. But you'll notice I've got black, blue, and green, and orange. When you do an inner join, it matches up where things have a commonality between the two. Usually a primary key and a foreign key. Usually. It doesn't have to be that way, but that's usually what you use. And in this case, I'm using color as the matchup. So if you're doing a straight up join and you're matching across blue, you'll end up with 2 and A and 3 and B. Because from the two tables, these are the records that match on a point of commonality, thus the color. As you can see, there's no black that made it across because there's no black in table B, and there's no orange that made it across because there's no orange in table A. Thus, it's not what they call an inner join. There used to be a phrase called a full join, and somehow they changed the meaning of a full join to something else. But basically what it means is that it joins only where records exist in both tables that have matching criteria, such as a customer and their orders. If you ask for a customer, give me all the customers that have orders, and you use an inner join, it'll only give me the records that have customers that have an order, period. Okay. Then there's left and right joins. And apparently I'm missing a piece here on my slideshow, but that's okay. My imagery disappeared and I was clicking like mad at the start of class, and it's gone. So that's okay. So if you've got the keyword join and you prefix it with left or right, this is where SQL gets a little weird. It alters behavior of the query. In other words, it'll return the unmatched data from the other table as a null. And the order is important because it uses the relative positions of the tables to make the determination. That's a right-left join. What I'm going to do is I'm going to pull this up here, then I'll do a demo. If I can find my mouse. Okay, this is a left and a right join. So as you can see, if you do a left join, it gives me everything on the left, plus anything that matches on the right, but the orange never made it across because it doesn't match. And it's a left join. In other words, it's grabbing everything from the left of the operator. If you do right join, the orange made it, but not the black, because it's everything to the right of the operator. And then there's the weird one down here called the full join. It just gives you everything. It just puts both tables together and just everything comes out. Now I'm going to do a little demo before I move on.
So the blank spaces would be nulls, right?
Yeah, they're nulls. It's just really hard to represent a null on a picture. Because how do you represent nothing in something that exists? It's easier to actually just do it as part of the, when I run the queries through. And yay, being unprepared. I was running a few minutes late, then I got sidetracked outside. This SQL, over here we go. Oh, really? Not that big. Okay. Okay, so far, just as a quick refresh from last week, this should look familiar. Bang. And that returned whatever, 10,000 rows. And if I do a select star from orders, and by the way, this is the ThinkCube database, which you should all have. Takes a little longer. Okay, so if when you look at the ThinkCube database, you've got an ID, an order date, a customer ID, an employee ID, an order reference, and order nodes. Here's our kickers right here, customer ID. Customer ID is a foreign key. It points to the ID of customers. So let's say I want to actually get all the customers that have orders. I can go from customers, join orders on orders.customers ID. Bang. Okay. So I'm going to stay sitting and I'm going to highlight stuff here. So I'm going to select everything, all columns, from customers. I'm going to do a join on orders. So in other words, I want the customers plus data from orders. The on clause right here specifies what the point of commonality is between the two. So that means I'm connecting from the primary key, customer's ID, to the foreign key, customer underscore ID in orders. And when I do this, this will take a little longer, but a lot longer. So I end up with 47,000 rows of data. Well, I got 10,000 customers. That means, some customers have up to 3 or 4 orders. And you see all the customer data here. And then you can see all the order data over here. Just like I retrieved from the order and from the customers, but now it's matching. So there's a few things we can do right now with this. And for starters, what we're going to do is we're going to clean things up a little bit. And this is actually going to cause an error. Make an error. It's going to cause an error. Let's see if one of you can figure out what the error means. Column references ID is ambiguous. Yeah.
Both tables have an ID.
Right.
You
So
have to specify which table.
exactly. And to specify, in other words, so the camera picks it up here, as he just said, both tables have an ID field. Therefore, the query parser doesn't know which ID you want. Therefore, it says, since I don't know what you want, I'm not going to try to guess. I'm going to tell you, I don't know what you want. Decide what you want for supper. Essentially. So let's say I want the customer's ID. If I run it again, it's just going to be the customers again. We're back to this. But let's say I want the name of the customer, the ID of the customer, and I can also do this. And now we got each customer with their order number or their order ID. Thus we got some data coming back. Query's running a little faster because I'm not asking for so much data. It's good for doing testing. Yes?
What is the difference between customer.id and customer_ID?
Customer_ID is a field in orders. Customer.id says, give me the column called ID from customers. And if I do orders.id, it says, give me the ID from orders. Yes?
So the top half is more the columns, and then the bottom part is more the tables in general, right?
But that's exactly it.
Okay.
So select tells what columns you're pulling. The from clause plus from until you hit the where, which obviously there's no where in this right now. So until you hit where, this is your table selection and how they're connected, and where's your filter. I'm not going to do any wheres for a little bit. So we got customer ID, orders ID. This is known as a table prefix. So you can tell it where it's coming from. I'm going to run it again. Okay, good. Now, there is one issue with this, the way it's set up now, which introduces the last basic concept of it, what's needed when you're doing joins. Have you guys covered arrays yet? No? Okay. It's always challenging. An array is a list. We'll go with that.
There's a list then. That's a list also as well.
Yeah, I know. It's a hash. But anyways, there's so many ways to describe an array, right? But anyways, basically an array is a set of values. And when an application queries a database server, so, later down the road when you learn how to program against a database server, not in this course, but you learn how to program against a database server, you end up connecting to the database server running a query. And what happens is, as you loop through the results at one record at a time, so it goes record 1, 2, 3, 4, do you notice what might be the problem? That we have the same field name listed twice. Now, languages like PHP, what will happen is it creates an array, and the first element's called ID, and it'll have number 6343 in it. And then when it goes and assigns the rest of the array, it sees, oh, ID is defined a second time, and it overwrites the original one. Why? Because they have the same name. It's not a good thing. So, in here, what we can do is we can actually use something called an alias. And I'll be covering more about aliases a bit later, because they're useful in many places. But you guys know, outside of database, what is an alias outside of database? It's an alternate name. What aliases in a database server allow you to do is it allows you to rename an object for the runtime of the query. It's not a permanent rename, it's a temporary rename. It's sort of like how you pick up the phone, you go, hello, this is Bob. Why? Because you just don't want to deal with the person. So here I could go and rename this as just straight up as order. Or actually order is bad because that's a keyword. If I go order number, for example, and I go and I run it, there's ID, name, and now it's order number. We've renamed the column. Now, there once was a time when we ran reports for managers where the report got printed. And what would happen is this would be sent straight to a line printer. How many of you guys know what a line printer is? Probably not many, if any. One. Hot damn, you're in the club.
My grandfather.
Thanks. That just aged me. A line printer used to be these big printers about the size of this desk, and there was a big box full of paper under it, and it used a ribbon, and it had to go back and forth on it, printing one line at a time. That's what they're called, line printers. And it really sounded like the apocalypse. It sounded like a chainsaw running. And what would happen is you'd create the report, and you'd output it directly to the printer. So it'd go from the query straight to the printer, and it'd go until it was done. And what would happen is suddenly you'd be getting a report and you'd have ID, something, ID and the names meant nothing. So we could use aliases to make things pretty. And I always trip up on Postgres' syntax here, so if it doesn't run the first time, please forgive me. MySQL syntax is a little different. I've been working on MySQL for a month now, so. And go. And I knew it. You have to use double quotes in Postgres. You can see in here the columns have been renamed with nice names. Totally useless if you're programming. But if you need to output just a quick data dump, for example, with this, I can save to an Excel spreadsheet and export it as an Excel spreadsheet, make the managers happy, or at least as a CSV. And I've lost my mouse. Where am I? Here I am. You didn't see what the dialog just popped up, but I will. As you can see, we have nice column names, so at least it's already exported properly. Okay, so that's an alias. You can use it to rename columns. You can also use it to rename tables. So for example, some of your table names might get excessively long. Customer available products. Gets a little long to start typing, especially if you need to refer to it in multiple places. So what you can do is you can actually just give alternate names. And this is where the syntax is different from the alias. As you notice, I didn't put the keyword as, because it just doesn't support, you don't put it there. So now if I go back and make this C and O, oops, that's C and O, you can see that it's a little shorter. It allows you to just give nicknames to your tables temporarily. So if you have to refer to that table multiple times, it's just C dot instead of customers dot. That's the purpose of an alias. They're used for one more purpose, but I'll touch that one up a bit later. Okay, so this is an inner join. I'm going to roll it back to the original syntax I had a minute ago, because it's a little clearer. To continue this. Bang. All right. So I'm back to the syntax I was using a little earlier. Any questions about the basic join syntax? You select your columns from a table, and you're going to connect another table to it on a point of commonality. You can have as many tables joined in as you want. The catch is, though, you can't connect to a table that's not ahead of it in the list. So if you were connecting 2 or 3 tables, it connects from the top going down, so that if you have the first table at the top refers to the third table, it won't work, but the third table can refer to the first table. The order of the table cares. You might get a weird error where it says, table not in table list. If that's the case, that's okay. You just need to reorder your tables a little bit or change how you're doing your joins. It's not an error people get very often. And the other amendment to this, do you have a question before I continue? Yeah.
Oh, no, you can finish that.
No, you go.
You know when you did the name?
Yeah.
You didn't specify which table it's from. Does it just assume that it's from customers because you put a comma there?
Which one here? When I put a nice name on it? Oh, name, because the column name is unique between the two tables.
Oh, okay.
So if I were to continue joining the tables, you guys remember the Think Cube diagram, I can go from customers to orders, orders to order line to product versions to products. Products has a name. So if I joined everything together, I'd get a conflict on name eventually. All right, does that cover?
Yeah.
Okay. Now, what was I going to say? I'm drawing a blank. Yeah.
I have a question.
Hopefully it jogs my memory for where I was going.
On your output,
Yeah.
you have two ID columns.
Yeah,
and
down
it's
here.
Printed out. How would you change the name of one of those?
That's the alias. I did it just earlier. I go as, and I give it a name.
Okay.
Like that. That's an alias. And now if I run it, I've renamed it.
Then that brings me to the next question. If you were select star, if you're bringing everything out, can you rename one specific?
Yes, but you end up doing star, comma, whatever the column is called, as something else. Then you get two copies of the column, one with its original name, one with the new name.
Okay.
Oh, okay.
It's horrible. So very rarely do you use a select star when you're doing a join.
Okay.
You just don't. Okay, not an alias, not a join. All right, anyways, I'm going to move on and hopefully my memory jogs where I was, because I really did remember until I started talking what I wanted to say. It wasn't that important though, I don't think. Oh, there we go, remembered. Now, as I've been saying, you join on a point of commonality. In other words, so far I've been joining from a primary key to a foreign key. Now this is important that you remember this. You don't have to join across keys. You can join against any given column against any other given column. For example, you've got two tables. One's a table you've been using for a while, one's a table you imported from someone else's database. And you happen to connect them between them, and the only thing in common is an email address. So neither primary key makes sense. There's no foreign key, but you can join across email address or postal codes or phone numbers if the phone numbers are formatted the same. You don't have to join against keys. You can join against any given column. Not always useful. Or you could do something that ends up looking like this, which is going to be totally useless data. I'm doing a join across primary keys. Of course, there's going to be matching primary keys. They all start at 1. Is it going to be the right connection? No. Because I'm going to do the join right now, you'll see what's going to happen in a second. And it's taking a little longer, as you can tell. Or it didn't run at all. Cool. Oh, I know why, because I cleaned up the data so I couldn't do it. Yeah, so bring this back. Okay, so this is a standard join. In other words, an inner join. It only matches records that exist in both tables. Now what I'm going to do is I'm going to do a left join. And that's where we pay attention to where we put the keywords. So we want to select everything from this table, and we're going to left join orders. That means I want everything from customers plus anything that matches on orders. So I'm going to do a quick sort. I'm in a quick search, and I need to order it. And I got to descend it. Hang on. All right, here we go. Left join. We have customers, We have all the customers. So down here we have 47. I can't see the number on this screen. That's why I have to turn around. 47,400 and change. When we do a left join. When we do a complete, like a regular inner join, we have 47,300 and change. 47,300 and change. 47,400 and change. What does that tell me? It means there's 100 customers that have never placed an order. So if we scroll through the results after the first 100 or so, there are 115. You start getting records with an ID, IDs in both columns. These guys up here are customers that exist that have never bought anything. Now, what is useful? What is the use of this? It has a bit of a use in the sense that, yes.
Wait, that they've never bought anything?
They've never bought anything. They have no orders. They're just customers in the system that never bought anything.
Take them out because it's useless data.
Well, not necessarily. They might be about to buy something.
Oh, right there.
Maybe they're a lead. Maybe they're a customer that registered an account and they just haven't bought anything yet.
Oh, okay, yeah, makes sense.
They're just
yeah,
customers. On the other hand, you can use this exact same thing to search for products that have never sold. So you select everything from products, and you do enough joins down to order lines, eventually you'll find products that have never been bought. No, I'm not showing you how to do that because of reasons. It's lab / assignment / tests kind of reasons. I'm not going to put the answer up on the screen. I just hand again? Someone? No? Yes, you? No? You? No? Okay. I thought I saw a hand for a second pop up. So the reason you'd use left and right joins is literally to find data where there's things missing. And I can put in a where clause in here, go where order.id is null. And that gives me my 100 customers that never bought anything. So I can actually literally search for customers that have that never placed an order by adding a where clause. And you can do the same thing with the right join. You just flip it. So instead of grabbing everything from customers, you grab everything from orders. But the database is set up in such a way that you can't. This database doesn't let you create an order because the parent-child relationship is enforced. Therefore, it doesn't let you create an order without a customer. But if I were to do the opposite of right join, it would give me everything that was in orders that didn't have a customer. You tend to use this to find orphan records. So records that don't have matching data in a relationship. If it's a parent, that's good. If it's a child, it's not good. That means the referential integrity is broken. When would you hit that kind of circumstance? If you're working with a MySQL database that's older than 5 years old, there's a good chance you're going to hit that. Why? Because MySQL just started forcing referential integrity in the last 4 or 5 years. Before that, it ignored the rules. So you just create data willy-nilly and it didn't care. Okay. So that's basically the concept of a join. Do I have any questions about it before I move on? Going once, going twice, not sold.
Sir, if you wanted to delete that data, is there a way to get those two and delete from that data?
There is.
Just like that part, you know? Like,
It's just these guys.
Yeah.
Yes, there's a way of doing it. I'll show you one of the ways to do it in a minute once I cover the next topic.
okay. Would we ever need to do that? No.
Oh yeah, deleting orphans?
Yeah.
Orphans are bad. You don't want them. You gotta get rid of them.
Okay. You could also use it for like marketing purposes. Like in this case, like sending all these people an email to go on the site and
Get shit done? Yeah. Yeah. Exactly. Okay, so the next one we're gonna hit is subqueries. Joins are hard, subqueries are gross. Joins actually have line, but joins aren't that hard. They're just, difficult at first. Make sure you got it right. Subqueries are basically, it's a query inside a query. Back when the movie Inception had just come out, I used to make the joke about Inception queries. But how many of you have seen Inception? Hey, look at that. Okay, they're Inception queries. There we go. Good, it's not that irrelevant yet. He's still in the dream, you know. I just spoiled it for those that didn't watch it. Okay. Okay, subqueries are embedded queries. What happens is that they're run before the main query. It's a bit like in math when you solve the brackets first, and then you solve the outer equation, but you got to solve the inner equation first. Same idea. You can use it anywhere. You can use it as a field. You can use it as in the where clause, and you can also use it as a table. When you use it as a table, it's a little more challenging because of what it becomes. All right, so if you use a subquery in a field selection list, it returns a single value from a secondary table. In other words, you need to return one thing, and I got a typo in that subquery, but that's, you know, life. You can often use it to set initial values. For example, here I got a select ID from statuses where names equal to new from some table. Actually, I don't even need the from on there. And what that would do is return one value. You can't have a subquery that returns more than one value when it's part of the field selection list. Why? Because it has to be run uniquely for every line. And this is where it gets a little weird. Probably need to turn on the light, don't I? Okay. Now, when you use this as part of a field selection list, it can only ever return one column and one value. Why? Because it's supposed to return atomic data. In other words, singles. Now, there's a danger to this. If you do this and the outer query returns 1,000,000 rows, it's going to run that inner query 1,000,000 times. Now, most database servers in the last 4 or 5 years, the programmers have gotten clever, and they've started using their brains, and they're going, hey, I just ran this query, and it didn't change. So it caches the results, it passes the cached results. But it still goes to run it 1,000 times, 1,000,000 times, 10 times. But essentially, it gets run every single time for every row that's returned. Thus, it brings us to the concept of subqueries are heavy and expensive. They use up RAM, they use up CPU, they use up bandwidth. It sucks, but they're handy. The next one is when a subquery is used in a where clause. So, you use a subquery to generate a list of values. And this comes back to how I'd want to delete something from someone. So if I want to generate a list, and it's usually used with something called the in operator, in a list. So I want to select everything from order line, so where the product version is in, and then I want to retrieve, only give me the results for products that are active. That's how you'd write it. So what it does is it runs the inner query. Put a cap on that. It runs this inner query here, and it builds up basically a list. And let's say we had 5 products that were active. So we have 6 products. 4, 5, 6. You know. All right, and this one is active. So active, active, not active, active, and active. So this is the setup we have. And what it would do is, active is true, it'd return, and tell it to grab the IDs. So what it's going to do is it's going to select this one, this one, this one, this one. I did 6, didn't I? That one's true also. So it'll return those values. And the way it behaves, it'll take that subquery and turn it into something that looks like this. Why are you too big? It'll take the other table, the results of the other table, and turn it into something that looks like that. In memory. You never see it do it. But it basically builds up a list. And it goes, give me everything more lines where the product ID is in this list. 1, 2, 4, 5, 6. 1, 2, 4, 5, 6. It's based on the criteria. This is used often to go and retrieve values from another table when there's a full set. Believe it or not, there's not a lot of slides today because there's more demo. Now I'm going to skip the last slide, the last 2 slides for a moment while I do a bit more demo time. So you can actually see what I mean by the subqueries when they're actually operating. Okay. That a little bit bigger. Select star from orders where customer ID in a given list. And now this is going to cause an error. Just saying right now. Subquery has too many columns. I wrote it like that on purpose so you could see this error message. If you get this error message, that means you want to use a star somewhere and you shouldn't. But if I say return ID and I run it and it returned 473, there's 473 orders for the first 100 customers. So here's the list that it would have selected. I'm going to just highlight that piece. See right here? It goes from 2 to probably 100. Yeah. So 99 customers. So this is the list, as I did over there. And what it does, it takes 2, 3, 4, 5, and creates a comma delimited list. And it turns it into in. So in other words, it takes these brackets, resolves it, and returns it as a list. And then you go select star from orders where. This is actually a useless query because I can actually do it with a join faster. But it gives a good example of how it works. Now, earlier, he asked how I could delete the orphan customers, or the customers that don't have orders. And he's not paying attention right now while I'm doing it, which is the best part. See, he's not paying attention at all. I'm talking about him and he's not paying attention? Yeah, you. You know what you asked earlier, how to delete the records that didn't have, the customers didn't have an order?
Oh, yeah.
I'm about to show how that would be done.
Oh, okay.
So, ID equals customers dot ID. I want to do a left join. Oh, come on down. Left join. Okay, does this query look familiar? It's pretty much the one I did earlier, and I definitely don't want a semicolon in that. If I run this, I lost my mouse. There it is. And I got a syntax error. Orders. Try that again. So here's my query I had earlier. Now that I actually managed fixing it. Oh, come on. Where? I just should have kept the original query up on the screen. There we go. So here's the list of our customers. That doesn't have it. Let me go get my history. Because obviously this worked earlier. It's nothing worse than join on orders this. Oh God, I hate it when I type something and I can't make it happen again. Oh. There we go. All right, so here's our customers, 115 rows that don't have an order. Now, let's say I want to select all the customers, or all the, if this is all the orders where the customer is in this list, this should return nothing because there's no customers. If I were to turn this around and go where customers, from customers, where ID in this list, now here's the list of customers that don't have an order. And I could literally just change this into the word delete. I'm not going to run it because it's going to wreck my database, so I can't help people later and I have to reload everything. But if I do that, it'll delete 115 customers. And that's it. So let me explain to you what's actually happening here. If I can get my cursor back where it belongs. I'm going to change back to select star so I can run it. Okay. Actually, I can get a little clever. A little more clever. Can move that down. I'm going to aim my camera over here. Oh, yeah, I can do this. Oh, they got their screens on separate things. Fantastic. Oh, come on. Okay. Here we go. I get to draw it right on the screen. All right. So what's happening is over here, this grouping here is my subquery. As I did earlier, is I'm retrieving a single value from customers here. Now, I'm doing a left join. What our left join does, it says I want everything from customers, because customers is to the left of the word join. I know it's above it, but if you were to put it all on one line, it'd be to the left. And then I want to connect from orders, right? And our points of commonality is the customer ID from orders and the ID from customers. And then I have a where clause down here. I'm just going to go get a different color here. My where clause says where the ID from orders is null. Holy crap, they're loud. I want to do a passive-aggressive door slam. Those of you that have been in the labs and D-building on the third floor are going to see me do it. Okay, so what this is going to do is this whole thing builds a list of IDs. I'm going to put the word customer in bracket here. That do not have an order, that's what it returns. Then it takes the results of this and passes out. And I'm missing my last, well, there's my last bracket right here. So it takes this, returns numbers. 2, 3, 4, 5, 6. That's basically what's passing out as numbers out of that query. Then what it does, it turns it into basically a common delimited list if you want to visualize it that way. So it takes all of this, turns it into a common delimited list. Then it's going to say, give me everything from customers where they're inside that list. That's what the in does right here. The in operator means in this list. And the list is now numeric. And then to delete it, we change this and we turn that into delete, like such. Does that make it a little clearer when I start drawing pictures on the board? And you'll never guess who gave me the inspiration of writing on the board through like that. It was somebody teaching English. I walked into her class as she was doing that with her students. I thought it was the greatest idea ever. But she was highlighting words. It works. I know my camera's all out of whack. Okay, now I'm going to kill this light because everything is dark. Okay, so the next one is where things get a little weird, a little extra weird, let's say. Okay, there's the last one called, basically it's known as a derived table. When you create a subquery, like I just had on the screen, but it is part of the selection criteria, as in the from. This is known as a derived table. It's how you, if you remember last week I said you can't aggregate an aggregate, this is how you'd aggregate an aggregate. I'll do a demo in a minute so you can see. It always has to have an alias, otherwise the server does not know what that table is supposed to be called. In other words, it creates a virtual table in memory, runs a query, takes the results, puts it in memory with a name, and for the rest of that query run, it behaves like a normal query, like a normal table. These can be expensive. Oh, they're leaving. I was about to go. I've never heard such a loud gaggle of people out in the hall. It's obnoxious. Especially when you're feeling a little ADD. It's really annoying. So I'll be doing a demo in a minute of how you'd use what they call a derived table. And then there's just one more. I want to get rid of the last slide. There's something called a correlated subquery. That's when a query refers, the subquery actually refers to a table on the outside. They're not as used commonly. They're really expensive. I won't even show you how to do these because honestly, I think I've used it 3 times in the last 20 years. If you really need to know how to do it, I'm sure you can Google. The problem is with the correlated subquery is that it's executed for every row of data being returned. And it cannot cache the results. Unlike the example I had here where it caches the results, it's unable to cache the results of a correlated subquery. Therefore, it has to rerun that query every single time. Now imagine if you're nested 3D. Okay, table A has 100 rows. Table B has 100 rows. Table C has 100 rows. And it's a correlated subquery that goes up 100 times 100 times 100.
10 lakhs.
Eh?
10 lakhs. Oh, 1 million.
Yeah, 1 million.
Yeah.
That wasn't English, was it? 1 million rows. It'll have to run that query 1 million times. As opposed to maybe 1,000 times, 100 times. It'll run it for 1 million times. It's expensive. Unless you really need to do it, don't. Why? Because it's usually not worth it. There's usually a more elegant way to handle it. Normally with a join, you can use derived table to help reduce some of it. Just avoid the correlated subqueries. All right, I'm going to do a derived table. Okay, I'm going to go limit 100 something you haven't seen before. I said I just want the first 100 rows because I got to remember what they're called. All right, here's our extended price. So let's go. So this is something I did last week. I created an aggregate. And here it is. So here's our sum grouped by the order ID. That is what an aggregate function. Did I do aggregates last week? Yeah, I did, didn't I? I put the dump up from it. So yeah, I did. So there's the aggregate. In other words, I just added up all my order lines broken down by order ID. This basically is the total for each order. That's what this is doing. And as I said before, what you can't do is you can't run an aggregate on an aggregate. So let's say I want to know what the average extended price is. Error message. And it says aggregate function cells cannot be nested, or calls, I guess that's what it is. My writing on my screen is like that big. So you can't nest aggregates. But this is where you can use so as you see right here, I created a subquery, but it's actually part of my from. As I said earlier, if you use a derived table, it has to have a name, so you have to use an alias. This is where aliases are extra important. So you run a subquery as part of the from. And at this point in time, the whole thing treats it like it's a normal table. It doesn't have primary keys or anything like that. It just treats whatever data is in it as the gospel truth. And here's where we can do our average. And actually, I need to give this a name. And I'm going to call it sum order. And I can grab the average from there. And there's the average order total. All right, so I'm going back to drawing the board. All right, here's what it's going to do. As I explained last week, there's something called aggregate functions. This is an aggregate function, and since it's a function, it has brackets. Okay? It's doing a sum. What does sum do? It adds up the values. Now, I want to grab, it's coming from order lines. And I'm grouping by order ID. So what this is doing is it's running a query. It's going to actually create a virtual table in memory, a temporary table. And this table is going to have two things. It's going to have a summary, and the order ID comes out of it. And this, when it's run, looks just like a table that has two columns. Now, since you're not allowed to aggregate an aggregate, you end up having to use it as a subquery, and you go on the outside and you use a second aggregate. In this case, it's going to use average. But here's the kicker. Do you notice right here? That's in brackets, right? Some order is my alias I've got over here. I've got this alias right here. When it passes out of the derived table, it returns it as whatever alias you gave it. And then I'm running the average on that, which gives us this. Now we can get really fancy. Since it's the end of this lecture, I'm going to fancy this one up a lot. And let's see how many tries it takes me to get it right. Because I try not to memorize this particular query. Here's a valid business question. I get this one at work every once in a while. Like, table structure is different than this, so it doesn't apply as much as it could. That's a really shaky cam for whoever's watching, maybe watching this later. Oh, really? So often I get a request from the marketing group. Can you tell me what customers have placed orders recently that are greater than the average order total for the last month? Right? In other words, I want to know who's actually the big spenders as opposed to the bread and butter customers. Because some of our customers send us checks that are 6 figures every month. Other customers send us checks that are like $500. When we start pushing big marketing campaigns, we want to go after the big spenders because they spend lots of money. When they spend lots of money, we get to have pizza on Fridays. It's a bonus, right? So when he asked me for this query, I hurry up and I write it. All right. So far, with this, I was able to figure out what the average extended price is. This is where we can see where you can start nesting stuff to your heart's content. I'm going to run this again. And this now I got a nice name on it. All right, so what I want is, that's one subquery, and I want come on. It's a really long query. Okay, I really wish there was an easy way to format that. So I don't fit on my screen. Did I get it right? Hot damn, I got it right on first try. Okay, here's what's happening. Like that. Like this. Actually, this one here's not even that important, but we'll leave it there anyways. Okay. I get the marker stuff up again. This is the worst it's going to be, honestly. I think it's probably one of the worst queries I write something like this at any given point in time. I'm actually going to bring my camera over so it's got a really good angle on the screen. Okay, so on here we have a complete mess of subqueries, essentially. So previously I explained what this was doing, right here. All right, this is that is summing an order. In other words, setting it up broken down by orders. Now, this one is it's calculating the average, just like I did earlier. There's nothing new about this one. This is where things get a little special. As you can see, this is a subquery right here. And what I'm also doing is I'm missing my top half. Thought this looked fishy. There it is. Oh, now my line's lined up. Snap. Time to draw it again. I definitely don't have enough sleep today. That's for sure. Okay, do it again. Okay, that's the order totals. That's the average order. Now I got one more right here. This is a derived table. Okay, so this is a derived table that calculates the order total. Okay? Then we end up with just the last two bits. As you can see, everything that's circled right now is pretty much all subqueries, right? And actually the blue should go up to here because where I got my bracket. There we go, like that. All we got left is this bit up here. Select star from. So it's going to select star from this. What does this return? The sum and the order ID. And then when I do the where, as you notice, I'm doing a where 8. That's referring to the alias of the derived table. And then it's saying where the sum or of the order, right, this guy right here, is greater than or equal to the results of those two subqueries. So I took the original subquery I wrote to find the sum. Then I found the average. Then I literally took this, copied it a second time up here, and I'm comparing the sum to the average so I can see which ones are greater than or equal to the average. Thus, we want our customers that are giving us the biggest amount. Actually, right now, this isn't even doing the customers, it's just returning what orders. Theoretically, here I could add a join to the customers and give me the list of customers itself. That'd be the last step. Believe it or not, I'm not asking you to write anything that looks like this, ever. But But that's essentially the power of the join, where I can actually calculate some data, manipulate it, and actually give you some meaningful results out of it. And with the order ID, here, if I wanted to actually connect to the customers, I could either connect from orders, or I could actually add the customer ID to here. But then this would mess up my my grouping. So we actually want to join the orders, then we join customers to the orders, and onwards and outwards. Okay. That takes care of that. Now let's not drop the camera this time. Let's be extra gentle. Everybody's favorite topic, yes.
So, sir, what do you expect us to know how to do by heart if you ask us to? So basically, just
There's one of the labs asks you to create subqueries. They're only single level subqueries.
okay. So just like taking two columns from two different things,
Or calculating the average of a sum. So that's the worst you're going to get.
so like that.
Yeah.
Okay.
What I've done on the board is very similar to what's in the labs. This is just taking it to the next level out.
Okay.
Like if I added a couple of joins in this, I would have literally in one query covered everything I did today. It's a little excessive. There'd be too much on there to understand. All right. Here come the announcements for the day. Yay. Ooh. Ooh. I don't know if I should feel offended.
Drop career.
Okay. The joy of the assignments.
Sorry?
I have good news and bad news. This assignment's a two-part assignment. That's the bad news. The good news is you get to do it by yourself. It's not a group work one. It's going, the group work things went so well this time that I'm not doing it again. There is a technical term, and I can't say it on camera for how well the group work went. Whatever reason it was, that things went horribly wrong, but you guys had 3 weeks to do a project as a group, and some of you have to work by yourselves, and I understand that that's life. But getting emails 3 days after the assignment is due saying my group's not working out. One of the core reasons for doing group work is to learn how to work as a group, right? And that includes personality conflicts. We all have to work with someone we don't get along with. 2, identifying issues when you're working in a group. When, every day, I get this at work where I have to deal with a specific worker and I know he doesn't do anything. Why do I know he doesn't do anything? Because his code repo hasn't updated in 3 weeks. Stuff like that, that's part of the group work. That is what you're supposed to take away from this on a not graded side. But, okay, camera, let's not focus. Just do it for Dan. It's not liking the lack of light. My focus length is gone. Anyways, whatever, I'll be blurry. As long as the screen's clear. So this is a 2-part assignment. The first one is set up, the first half is you're given a broken diagram. By broken, I mean it's a mess. And if you read the description on there, let's see if I can zoom that in a bit. Okay, pretend you're a not so junior person and your junior handed you a piece of dog food because he didn't listen in his database class. And essentially what's happening is you've been given a diagram, you are to fix it. To bring it up to the point of what it should look like. The point is you have to be able to derive the purpose of the diagram and then clean it up. How bad is it? There's only 3 tables. You have to basically figure out what it's for. I know I'm not putting it up on the screen because then I'd start talking about it. You have to figure out what's in that diagram, and then you're going to clean it up and normalize it if it applies. You're going to properly diagram it, including naming conventions. And you can see half the points on here are naming conventions. And I just, actually my description there on the file name is wrong. It should be task 1, but that's okay. Last name, first name, assignment 1, task 2. I don't care if it's task 1 as long as it has your name on it. I'm going to change that so it's the proper description. I grabbed that from an old assignment. And I put in the naming conventions in again for your reading pleasure, so you can't say, well, I don't know what the naming conventions are. You know, considering the naming conventions are worth almost half the points of this first half of the assignment, you know, you might want to pay attention. Assignment number 2. As you can see, there's not a lot of detail because it's set up as a quiz.
Oh, it's a quiz.
It's a quiz, but it's not. Okay, this is using the ThinkCube database. There are questions. You're going to write SQL to figure out the answers to the questions. Basically, Lab 7 and parts of Lab 8, which is what you guys should be working over the next 2 weeks, will cover this material. As of now, lecture-wise, I've covered everything you need to be able to do this assignment. Just putting it out there. This is your preparation in a way for the practical exam. Because the practical exam is this format, right here. So you do this gets you ready for this is almost like your practice run for the practical exam.
What do you mean by practical?
As in you sit in the lab for 2 hours and you do this. It is a practical exam. It tests your practical skills with SQL. And it's worth 20% of your grade. So, this one here is your practice run. Yes?
So you said that for the assignment 2, we're going to be working on a database that has 3 tables.
There's 2 parts.
Oh, okay.
Part 1 has a database that is badly designed.
So
You're going to fix it. Part 2, I'll actually add extra notes to this so that it's a little clearer. Part 2 is you're working with a ThinkCube database, which you should have, and you're going to answer these questions.
Okay.
So you're going to run how many customers have their name starting with JA? You're actually going to run that query and say, well, whatever way you write a question that figures out how many people. So JA. I don't care how you write the query that gets the results. But it basically takes numbers or letters. It is very anal retentive, as some of you have discovered. And if I need you to actually be specific, I actually am specific in the instructions on what I want. For example, provide a number rounded to 2 decimal places. I'm serious, I want literally to 2 decimal places. If you don't put in both decimal places, it's going to ignore you. Fair enough? Due date, which is always the next question people ask.
Will both tasks be due on the same date, or?
Yes, they are. It's an assignment. You have until the 14th to do it. That's 2 weeks. The SQL side of it shouldn't take very long. Realistically, maybe an hour or 2. And obviously, if you're caught up with the labs, you actually don't practically have a lab period to do it. Actually, I think if I remember in the CSI, even allocate a lab period for it. And the first part is redesigning a database. At most, that should take you half an hour. It's not a killer assignment, but it should be fairly straightforward. Now, the other thing, you'll notice the hybrids are all due on the 21st. That's because you can probably guess what happens after the 21st. Yeah, the second test shows up after the 21st. Yeah, the due date on the assignment is the 14th. That is if you want your full marks. The drop dead date is the 21st. I just can't put drop dead dates in the calendar because it just doesn't. The 21st is the drop dead date for assignment 2. And like I said, I'm going to go clear up the wording a little bit on the assignments. I was doing that at like 1 a.m. last night, so I missed a few pieces.
What's 157 p.m.?
Where? The green one?
No, the one like under
I'm gonna fix that too. It's just Blackboard being stupid, accepting whatever default date is there. And it's not supposed to be the default date, it's just, it grabbed it anyways. Hold on.
In the when you say you want it rounded to 2 decimal places, do you want like trailing zeros for that?
No.
No. Okay.
Well, yeah, I mean, if it's, if the answer is 123.00, I want the 0.00.
But like, if it's like
21st.
2, you don't get the
Yeah.
Yeah, you do.
You said
Two
the hybrid
places.
test on the 21st.
Depending on what kind of move, hey, look at that, it started focusing. But, yeah, that's how it is. It's, Blackboard is anal retentive. That's just how it is, and you just gotta assume it's gonna be bad and not pay attention. I do go through it and
Test
correct
and
it,
hybrids
but,
do
you
21st.
know, there it is.
Is that
Alright,
everything?
that's it, boys and girls.
No.